now we are moving with this new topic, which is called as a ratio and proportions. And now this is again one very important chapter, one very important topic with the perspective of the quantitative section as well as for the data interpretation, data insight, like all those different sections which are having a diagrammatic questions based on like bar, graph, pie chart, and different diagram represented questions. Right. So, uh, three topics are important. One is the ratio and proportion, one is the percentage, and the third one is the average. Because in these topics, you will find questions based on quantitative as well as in a data interpretation or data insight or logical reasoning, right? The different names are there in different examinations, but the questions are same, right? So ratio and proportion. Okay. This we have done maybe in a class of eighth or ninth, way back, like in a schooling days, right? Okay, so starting with this first topic, ratios. So can you define what is ratio? How can I define the term ratio? What is this ratio? And now you can, I suggest for everyone to just like unmute yourself and then speak out, right? So that everyone can listen and they can also add up their points, they can add up their ideas. Yeah. So how will you define the ratio?
So,
Yes, Niyati.
for example, there is a solution,
Mhm,
and there is a salt solution in which
mhm.
the proportion of salt and water is equal. I mean, the ratio of salt and water is, for example, 1:3.
Okay.
One is for salt and three is for water.
Water. Yeah. Okay.
Uh, yes, so a ratio is the indication of the quantity that is
Mhm.
present, or
Okay.
ratio actually suggests the amount that is present in any like particular thing.
Okay. 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 So this is from Niyati. Any other person wants to say something? How will you define ratio?
So, hello, sir. Hello, all.
Yes, Nandini. Yes, Nandini. Yes.
Sir, I think like for me, ratio is like a comparison between two quantities
Mm-hmm.
in terms of numbers. Like for
Mm-hmm.
example, we compare boys to girls. We say boys
Mm-hmm.
to girls ratio is 2:1. So we are taking each
Mm-hmm.
other's reference for like we are taking girls number from boys numbers
Mm-hmm.
reference. Like we say
Okay.
boys are two times of the number of girls in the class, or girls are 1/2 times of the boys in the class, like that.
Okay.
That is the comparison that we get from ratio.
Okay. 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 And Hardik, I suppose you also wants to say something.
Sir, I also feel the same, like it's a comparison between two quantities. Like as mentioned in the example, if the boys is to girls, the ratio is given like 2:1. So the
Mm-hmm.
total component becomes three, right? And out of the three, one part is for
Mm-hmm.
the girls and two parts is for the boys. So out of the
Okay.
total, it also signifies some portion
Okay. Okay.
with
So
respect to the
like,
two quantities. Yeah.
okay.
Sir, I think ratio is a fraction.
Mm-hmm.
So,
Okay. So just this much ratio is a fraction. Okay. So there are some different definitions and different perspectives, different ideas, different points are there, right? So first thing is there are numbers like if we are comparing, so comparing count is not restricted as you are saying okay, two quantities, right? So this is not just limited to only two quantities. Ratios can be compared among any number of quantities, two, three, four, five, any number of quantities. Ratios can be compared, right? First thing. Second thing, as you're saying, the ratio is like comparison of numbers like boys and girls. So this is a one example, but we have to define this in the perspective of as a whole. So suppose if I say 5 liters of milk, right? And 10 kilometers of distance. Right? So as you people are saying, and Nandini said that this is a say comparison of numbers, right? So can I say here the ratio is 1/2? Is this 5 liters of milk and 10 kilometer of distance?
No, I think because it's supposed to be between same, I would say, quantities, or if it's liter, then it has to be the
Uh-huh.
comparison has to be in liters even.
Right, right. So suppose if I say this is not 10 kilometer of distance, if this is say 10 liters of water, then I can say the ratio is 1:2, right? So based on this, because we're taking normally the example of boys and girls, students in a class, students in a college, or maybe employees in an office, right? So because we are all the human beings, so there is a no such difference. But see, how will you define the ratio? Ratio is a comparison of numbers which are of similar units. Right. First point is ratio is a comparison of numbers which are of similar units. Right. So liters to liters, kilometer to kilometer, kgs to kgs, right? So units should be similar. First thing. Now, when you compare this and you are cancelling out, so liters will cancel liter. You are having only number that is 1/2. So the second point, ratios are unitless quantities. Right? Ratios are unitless quantities. Suppose if I say ratio is a 1:2, ratio is a say 3/5, right? So you cannot tell me that this ratio is representing what? Is this ratio of any solution? Is this ratio of boys and girls? Is this ratio of say some production, some product in the organization, right? So if I am giving you just only the figures, just only the digits, 3/5, maybe say 10/11. So you cannot tell me that this ratio is representing what? Because ratios are unitless quantities. You will never know is this liters, kgs, kilometers, what are the units of the numbers, right? So first point, ratios are the comparison of numbers which are of similar units. Second point, ratios are what? Unitless quantities. Right? And the third point, ratios are represented in the simplest form of the numbers. So suppose if I take this example, 5 liters of milk and 10 liters of water. So you can say ratio is 5:10, right? But representing the ratio in terms of 5:10 is not correct. Whatever is the common part in the numbers, I need to remove that common part and I need to simplify the numbers to the simplest forms. And what is the simplest form? This is 1/2. So if you are saying this is 1/2, so here, how can I identify that this is simplest form? HCF. HCF should be 1. Highest common factor of the numbers which are representing ratios should be 1, right? Or in other terms, we have a say one technical term for this, that is number should be what? Co-prime, right? And what is the definition for co-prime? When the numbers are having highest common factor is 1, right? So first point, ratios is a comparison of any number of quantities, 2, 3, 4, 5, right? Any number of quantities, not only restricted for two variable or two quantities, right? Second point, ratios is a comparison of numbers which are of similar units. Next point, ratios are represented in the simplest form of the numbers, right? And what is the simplest form? When the highest common factor, HCF, is 1, right? So this way we define the term ratio. And this understanding the definition is very important, because when we solve the questions, when we solve the problems based on ratio, so if we are not having a clear understanding of this definition, sometimes we stuck and we make wrong answers, right? So this clarity should be there. Okay, now moving further. So, moving further, whatever we have discussed, so this is just a definition. So, ratio and proportion are majorly based on fractions, as Preeti just said, they are represented in terms of fraction. And ratio and proportion are two important concepts. So, as I told you earlier, ratio and proportion, percentage, and average are very, very important, right? And these are used in our daily life when you're cooking food in the kitchen, when you are, say, working in your office. So you're just putting up and managing your time, dividing, say, first half or second half in different working style, right? So ratio, how can I say? Comparison of two quantities by the method of division is very efficient, right? And the comparison or simplified form of two quantities of the same kind, see this, same kind, same unit, is referred as ratio. This relation gives us how many times one quantity is equal to the other quantity. So as you told me, that there are boys and girls, so ratio is, say, 1 is to 2, 3 is to 2, or whatever. So girls are 3 part, boys are 2 part. So we can just identify the number. And two ratios can only be compared when they are having a same unit. See this, multiple time this one particular statement are repeating here. And the ratios can be represented in these three forms: A to B, A is to B, or A by B, right? So all these three different representations are correct to represent any ratio. Okay. So just remembering these some key points. So the ratio should exist between the quantities of the same kind, right? Again, the same thing is repeated. So this is a very, very important part. Ratios are the comparison of the numbers which are of same units. While comparing two things, units should be similar, right? There should be a significant order of terms. So at least two terms should be there to have a ratio, but 2, 3, 4, 5, right? Any number of terms can be there. Comparison of two ratios can be performed if the ratios are equivalent, like the fraction, right? So ratios are represented in the form of fractions. Then only you are able to identify the ratios, right? Okay. Yeah. So if we are having a two or more quantities, right? So ratios can be represented at A is to B or A by B. And in this, the numerator is called as antecedent and the denominator is called as consequent. So if I have a, say, 4 is to 9, so 4 is the antecedent and 9 is the consequent, right? And ratios are represented again in the what? Simplest form of the number, where highest common factor should be 1. Okay, so different types of ratios. So suppose if you are saying, I have some ratio like A by,
Sorry
yes,
to interrupt.
yes, yes, yes.
Just above the types of ratio, we saw something about multiplication division or something. So
This
so
one?
the last part, yeah. If you multiply and
Okay.
divide each term of
Okay.
ratio by the same.
So this is if we multiply and divide each term of the ratio by the same number, that is a non-zero. It does not affect the ratio. So say, as you people are saying, the ratio is, say, 2 by 3, right? So this is the simplest form. But if I change these number and multiply or divide. Suppose if I multiply with the what? This is each term with the same number, right? Same number in the numerator, in the denominator. So if I multiply this, suppose with 2, and this is also 2. So what is this? This is 4 is to 6, right? But still, the ratio remains the same, that is 2 by 3, right? If you multiply this with, suppose 3, so this is 6 and this is 9. Still, the ratio remains the same, that is 2 by 3, right? So when you are multiplying or dividing the ratios with the same number, then there will be no change in the ratio. Only the figures, the numbers are changing, but ratio remains the constant. And this is the reason we are talking about that ratios are unitless quantities, because these are the just simple numbers, nothing. They are representing magnitude, right? How much. They are not representing what, right? So ratios will not change if you are multiplying or dividing, right? Got it?
Yes, thank you.
Okay. Okay, so different type of ratios. First is compounded, duplicate, reciprocal, right? So if I say ratios are something like A by B, C by D, E by F, and so on, something like this, right? So compounded. Now, compound. So I suppose that you people are also working for the English part, right? You're working and you're preparing for verbal, the English part. And in this, there is a one major thing we have to prepare for the vocabulary, right? We have to memorize the words. We have to work for the words, word meaning, antonyms, synonyms, so that we can have a say good understanding of RC passages, parajumbles, and different kind of questions which are there in the English, right? So one way of preparing for the vocabulary is root words, right? And what are the root words? Just like take example, phobia, right? So if I have a term phobia, so I know that the term is representing some fear of something, right? So if phobia is there, I know, okay, yeah, this is representing some fear. So there are different kinds of root words which are there, right? So in this also, if you can find out, see this is a one root word, COMP, right? Compound, component, compare, complex, computer, right? So all these words are having comp, right? So if I am not getting exact meaning of the word, and if I know the some meaning of the root word, I can just imagine what can be the possible meaning of the word, right? So comp, if I know all these words, computer, complex, component, compound, right? So I know there are some small things. Take example, computer. So there are various parts in the computer, and when you assemble all these parts, you're making a one big thing, right? Similarly, complex. I normally say, okay, this problem is very complex. So this means what? There are some small thing making up some complex thing, right? So what is this compound? Some small things are joining together and making us some big thing, right? So this is what compounded ratio. So in a compounded ratio, if I have A by B, C by D, E by F, so what to do for compounded ratio? I multiply all the numerators and I multiply all the denominators. So for this, compounded ratio is what? A into C into E, right? Divided by what? That is B into D into F, and so on. Right. So this way, if you are not getting a say some meaning in the examination, I suggest try to work with root words so that you can just imagine, you can just guess what can be the possible meaning of the word, right? And then you can solve the questions, you can understand the basic idea of the sentence, what is written there, right? Okay. So this is compounded ratio, multiplying all the numerators, multiplying all the denominators. Okay. Duplicate ratio. Now, how to work with this and how to understand this? So I suppose you people are filling up the forms in the college, or maybe some different competitive exams, or maybe like you are filling a form for your Aadhaar card, driving license, etc. Right? Particularly the government offices. So when you're filling a form, so the person sitting there, so the person just scans through the form. Okay, this is correct. Now just give me a copy of your residence proof. Just give me a copy of your educational qualification, right? So what do? You just take a photocopy, right? So this is what? This is duplicate copy of your testimonials, right? Duplication, double, doing something double, duplicate, same thing, right? So what is duplicate ratio? Multiplying the same ratio 2 times, right? Suppose if I ask your date of birth, right? So you say, okay, this is my 10th mark sheet, right? So because this is used particularly for the date of birth, right? So you're not giving the original mark sheet, right? You're giving just taking a photocopy and then giving. So what is this duplicate copy? So the same carbon copy, right? So duplicate is what? Multiplying the same ratio 2 times, right? So this is what? A into A, B into B, taking out A square upon B square, right? So this way you can just add up the things. Duplicate ratio, multiply the same ratio 2 times. Triplicate ratio, multiplying the same ratio 3 times. Quadruplet ratio, multiplying the same ratio 4 times, and so on, right? So just with a name, you can identify what to do, right? Okay, reciprocal ratio, taking the reciprocal 1 upon. So this is just simple. If ratio is A by B, so you can say 1 upon A is to 1 upon B is what? My reciprocal ratio. Or this can be written as what? B is to A. So if the ratio is A is to B, so you can say the reciprocal ratio is B is to A. Just the reverse, right? Okay. Ratio of equalities, the same ratio. Like we say, okay, this is say sugar and water solution, and the ratio is 1:1. The same part, right? So this is a ratio of equality. Numerator and denominator both are equal. And ratio of inequality, when the two terms, numerator and denominator, are different, right? So these are the different type of ratios. Okay. So moving the next part, which is a little more important, and this is comparison of ratio, right? And which is normally there in the examination, comparing ratio. And even as you are working, so you must be comparing, okay, I need to compare the production for the last year to this year, right? So this is what comparing the ratio. Now, how to compare this? So I'm just taking up, say, some numbers to give you the values, right? So, okay, yeah. So first come to this, give me the answer for this. If A is to B is 3:5 and B is to C is 9:4, then what is the ratio for A to B to C? Yes.
Sir, 27 ratio 45 ratio 20.
Okay. Okay, Hardik. Okay, yes. Okay. Others, I'm just waiting for your response, for your answers. If A is to B is 3:5 and B is to C is 9:4, then what is A to B to C? So Hardik, how is this 27, 45, 20?
So basically, we'll compare the value of B and we'll try to take the LCM of it in both the scenarios, in the first equation and the second equation. So we'll get it as 45. So we'll multiply A is to B by 9. And the second B is to C by 5. So in both the scenarios, the value of B becomes equal. And if that becomes equal, so A is to B is to C is then the final answer.
Okay. So see, there are multiple ways. This just depends what is the kind of numbers are there and what method strikes in my mind when I am sitting in the examiner, right? So I'm just discussing a different ways of solving this. First, A is to B. This is given to me, and this is 3 is to 5, right? And B is to C. This is given to me, 9 is to 4. Right? So in this, my 1:1 element is common, which is B. So the first is what? LCM method. So what can I do? I can take the LCM of these numbers. LCM of 5 and 9. And this is coming out to be what? 45. Right? Okay. Yes. And now if I need to make 5 as 45, what to do? I need to multiply this with 9. And if I want to make 9 as 45, what to do? I need to multiply this with 5. Right. So now I am getting my answer. 9 into 3 is 27. 9 into 5 is 45. So this is the first equation, upper part. And second, 9 into 5 is 45 and 5 into 4 is 20. Right. So this way I am getting my answer. But in this, because the numbers are easy, so I can easily calculate and I can easily identify who it is the LCM, right? But sometimes numbers are little difficult and little bigger. So alternatively, what I can do here, see, I have A is to B, right, which is 3 to 5. And B is to C is what? This is 9 is to 4. Right? Now, write the same way. Now, what to do? Multiply this. Right? Multiply this. And multiply this. So, this is 3 into 9, 27. 9 into 5, 45. Right? And 5 into 4 is 20. So this is the same answer I am getting without taking the LCM of the numbers. But yes, I need to just multiply little slanted, right? I suppose everyone is getting at this answer. Okay. Okay. So tell me this one. A is to B is 3 is to 7. C is to D is 2 is to 9. A is to C is 5 is to 4. Then find the ratio of A to B to C to D. Yes. What can be the possible ratio for A to B to C to D? Okay, Tejaswin. Okay. Okay. Okay, shares. Okay, Hardik. Okay. Mm-hmm. Ashna, maybe not. Maybe not. Ashna, how is this your answer?
So I basically wrote all of them the way we did in the previous question, and then I use the multiplication method that you told us. So
Okay, but see, the difference here is in the previous one, you are having a terms in a order. A is to B, B is to C, right? So this is the order. Continuously, you are moving one step forward. But if I look for this one, right, the question, so this is what? A is to B, C is to D, A is to C, right? So there is a no continuation, right? So sometimes the examiner are mixing the terms and they are just creating a trap for us, right? So see how to get this answer A to B, right? And C to D, A to C, right? So what I do, I just write this ratio in a little twisted manner. This is B to A, right? And A to C. So A to B is 3 is to 7. So B to A is what? 7 is to 3. Getting this? And what is A to C? This is 5 is to 4. Right? This way, right? So you have to work a little tweaking, right? Now I can identify this. So what to do here? Multiply this one, multiply this one, and multiply this one. So 7 into 5 is what? This is 35. Okay? 3 into 5, 15. 3 into 4, 12. Right? And now what is the C is to D? So C is to D. So how much is this? 2 is to 9. Right? And I need to calculate this. So now what to do? Multiply this, this one, and this one. Right? So when you multiply and simplify, so 35 into 2, 70, 15 into 2, 30, 12 into 2, 24, right? And 12 into 9 is how much? 108. Done? Now, what is the order of these ratio? This is my B ratio, this is my A ratio, this is my C ratio, and this is my D ratio. But I need to find the answer as A to B to C to D, right? So if I need to calculate A to B to C to D, so how to get my answer? This is 30, this is 70, this is 24, and this is 108. Right? But ratios are represented in the simplest form of the numbers. I need to take out the common, right? So the common is what? 2 in this, right? Entire ratios, all 4 ratios, 2 is the common. So just taking out 2, so this is 15 is to 35 is to 12 is to what? 54. And this is my final answer. Right? So the ratio of A to B to C to D is what? 15 is to 35 is to 12 is to 54. Right? Akshay, no, this is not correct. This is not correct, Akshay, right?
all right.
Okay. So if I have, say, some multiple ratios, okay,
So,
so tell me, yes,
so in the above question, like, is there any other way to find out rather than doing this entire, like, just asking?
other way is the LCM, है ना? So what we have done, so first here I need to take the LCM of this part, right? First I need to take the LCM of this, and then I need to simplify. Then I need to take the LCM of this, right? Because now this is common, and then need to simplify. So 2 times I need to take the LCM and then simplify, right? Okay, so Maneet is saying, but why we took BAC and not ABC from the start? Okay, so Maneet, because see the order, right? If I take ABC, right? I write here. If I take A is to B is to C, done in this order. So A is to B is what? 3 is to 7. And then I take in this part common, right? That is AC. So this is A is what? 5 and this is 4. So now if I take a LCM, then it is okay, right? If numbers are small. But if I take this cross slanted multiplication method, which is a little faster way, so I am not able to solve because there is a no slanted situation, right? So this is the reason I'm just creating a common ratio in between, in middle, right, Manit? Okay. Okay. Now come to this. If I have the ratio of this kind, okay, Hardik, okay. So if x is to y is 1 by 4 is to 1 by 3, then what is the ratio of x to y? Okay, Tejaswin, okay, Hardik, okay. Okay, Kuntal, okay, Shreyas. So, hello, Kuntal, can you unmute yourself?
Yes, sir.
So, how is this 3 is to 4?
So it's the reciprocal, right? So we just divide it and 3 goes up and 4 comes down. So
Okay, so what about Kuntal, this second one? If I have a x is to y is to z is 1 by 3 is to 1 by 4 is to 1 by 5, then what I can do here? Okay, now no
we have
worries.
to divide it by x is to y and then y is to z, like
No. Okay, so see, if you are having only two variables, just like we have a first example, that is x is to y, so nothing to do, right? But yes, we should understand the proper method, right? But nothing to do, and how can I say? You just reciprocate the number, right? You just reciprocate the number. So x to y is 1 by 4 is to 1 by 3, and the answer will be 3 is to 4, right? But why is this? I'm just telling you, right? Now, come to this first, the second example. Yes, Alan. Yes, correct. Second example. Now, how can I do this? Take the LCM of the denominator numbers, right? For all these numbers. So if I take the LCM, so this is what? LCM of 3, 4, and 5. How much? 60. Right? This is the LCM 60. So here, the x is what? So first you're taking a LCM and then take the LCM as the numerator of every number. So this is what? 60 by 3. Right? This is 20. Y. 60 divided by 4. How much? 50. And this is Z. 60 divided by 5. This is 12. So when you're calculating for x to y to z, so this is coming out to be 20 is to 15 is to 12. So this is my final ratio, right? The same thing will work in the first example, right? But because only the two variables are there, so we do not actually require this. So what to do? Take the LCM of what? 4 and 3, right? Denominators. This is 12. So what is x here? This is 12 divided by 4, which is nothing but 3. And what is y here? That is 12 divided by 3, which is nothing but 4. And you are getting the same answer. Right? But in a two variable, we are not actually doing this because we are just getting direct answer, just interchanging the numbers. Right? But if you are having a 3 or 4 or 5, 6 variable, so you need to take the LCM, put the LCM in the numerator part and divide with every denominator, and then you will be getting the ratios. Right? Okay. Now, come to this part. So this is a little important because proper application is what? Comparison of the ratios. Right? So we are having a this one 8 by 17 or 15 by 31. Tell me which ratio is greater out of these two. First, give me the answer for the first example, then we'll come to the second example. Okay, Hardik, okay, Indranil, okay, Niyati, okay, Preeti, okay, Tejaswin, okay. Okay, so hello Ayush, can you unmute yourself?
Yes, sir.
So Ayush, how is this 8 by 17 is greater?
Sir, I use the LCM method, and basis that 248 divided by 248 by 527 is to 255 by 527. So basis that 8 by 17 is the greater one.
Okay. Yes, Niyati, yes.
But in this one, the first one, what I thought was if we take anything, then it's 1/17th part and 1/31st part. So 1/31st part means obviously we will be cutting more, for example. So in that normal logic itself, 17, that would be greater one.
Okay. So so hello Akshay.
Yes, sir.
Which one is greater?
So 8 by 17 as per me.
How?
So I use the method of cross multiplication, and using that I got this answer. I taught this in my schools.
Okay. And you have some calculator, some mobile phone near to you, and can you do the calculation from the calculator and tell me?
Yes, sir.
Just check.
So 8 divided by 17 is 0.47.
Okay, 0.47 you are saying this is, I just write it here, this is 0.47. Okay, and how much is this?
Oh, yeah. So this is 0.48. The other one.
Right. So this is 0.47 and this is 0.48. Right. So which one is greater, Akshay?
Sir, actually I made a mistake in the cross multiplication, but the method was right.
I'm not talking about the method, but I'm just talking about how we interpret, how we say, because in the examination, right, we know, okay, this is a one method by to identify the comparison, to identify the, say, which one is greater or is smaller. But how do we interpret and how do we decide which is more important, right? So that my answer should not be incorrect, right? Okay. So I clearly say that this one is greater, right? 15 by 31. Now, there are different ways, there are different methods to identify the numbers. First, when I have this number, so this is 8 by 17 and this is 15 by 31. Okay? So what we do normally, we just cross multiply, right? This way and this is, right? So this is 8 into 31 and this is 15 into 17. Done? Now, with this, right, with this, can I just guess which one is greater? Left part or the right part?
The right part.
Right part, right? This is greater. This is greater, right? And in this, if I identify, this is the numerator of the left fraction and this is the numerator of the right fraction. And we are saying the right part is greater. So this means this is greater, right? One way, without calculating any numbers, right? Second, as I told you earlier, that average, percentage, and ratios are the important chapters in the calculation. So see this. If I write these number as first number 8 by 60, how much is this? 1 by 2. Easy. I can easily calculate. There is no calculator, nothing is required. Right? 15 by 30. This is again what? 1 by 2. Right? So now the two fractions are equal. 1 by 2, 1 by 2. Right? I suppose this is clear to everyone. Now we are doing, in the first one, the denominator is 17. So we are adding 1 here. In the second one, the denominator is 31. We are adding 1 here. Right? Again, easy. Right. Now, listen carefully. Very carefully. Adding a number 1. Right? Adding a number 1 in 16 or adding a number 1 in 31. Right? Adding a number 1 in 16 and adding a number 1 in 30. Where is the bigger change? Bigger change.
In 8 upon 16.
8 upon 16, right? क्यों? क्योंकि हम क्या कर रहे हैं, दोनों फ्रैक्शन 1 by 2 1 by 2 है ना? हमने क्या किया कि जो डिनोमिनेटर है उसमें हमने 1 ऐड किया. अब अगर मैं 1 16 में ऐड करता हूँ या 1 में 30 में ऐड करता हूँ, तो बड़ा चेंज, बिगर चेंज कहाँ पे आएगा? जब हम नंबर 16 में ऐड करेंगे, बिकॉज 16 इज अ स्मॉलर नंबर कंपेरेबल टू 30, है ना? तो क्या हो रहा है, आप देखो ध्यान से सुना. जब मैंने 116 में ऐड किया तो मैंने जो डिनोमिनेटर है उसको एक बड़े मार्जिन से चेंज किया फर्स्ट फ्रैक्शन में, है ना? क्योंकि यहाँ पे नंबर छोटा है, 16 इज अ स्मॉलर नंबर. और जब मैंने 1 को 30 में ऐड किया तो यहाँ पे जो एडिशन हुआ है वो एक बड़े नंबर पे 30 में हुआ है, तो यहाँ पे जो चेंज होगा वो कम होगा, है ना? बिकॉज नंबर बड़ा है. तो डिनोमिनेटर में जहां पे ज्यादा चेंज हो रहा है वो उस फ्रैक्शन को छोटा कर देगा, राइट? सो दिस फ्रैक्शन, द फर्स्ट वन will be smaller, right? And this 15 by 31 is what? This is a large fraction. Getting this? Got this? So in this, we are not doing any kind of calculation. We are just working logically, right? And if you work logically, right, these are the say shortcut and logical approach in the questions. And when you work this way, right, you're solving the question quickly and instantly. Right? Got this? So the first fraction 8 by 17 is smaller than the 15 by 31. Okay? Okay. Now come to this second question. 13 by 11, 15 by 13, 11 by 9, 12 by 10. Which one out of these four fractions, the greater? Okay. Okay, okay. Hello, Preeti. How is this 13 by 11 your answer?
Simply divided.
Mm-hmm. So you're dividing all the four and then checking the answer?
Yes, sir.
Are you sure that 13 by 11 is the greatest one?
I think yes, sir.
Okay, okay. And hello, Shreyas. Can you unmute yourself? Okay, okay, no worries, no worries. So, okay, so hello, Deepshikha. Can you unmute yourself?
Yes, sir.
So, which one is greater?
So 11 by 9.
How is this?
So I divided and checked as numerator is the bigger one.
So you are dividing all the four fractions.
No, roughly I just did like denominator is smaller and numerator is the bigger one.
Okay, okay. See, when you're going into the examination, so we need to say accurate answer normally, right? Exact answer, because making us say one answer wrong is what we are just wasting a time to attempt to think all the thing, and then whatever we have earned good marks in other question, we are just going in a negative, right? So we should be sure enough to get the answer. Okay. So one way is the cross multiplication, right? Taking a say two ratios and then comparing, right? Now other way is what? Yeah. So other way is first take this first fraction, 13 by 11. No? Can I write this as what? 1, 2 by 11 in the form of mixed fraction? Yes? Yes or no?
Yes, sir.
Right? Okay. Second fraction, 15 by 13. Can I write this as 15 by 13 as what? 1, 2 by 13? Right?
Yes, sir. Yeah.
Next
Hi,
fraction. Yes, yes, Ashni.
hi. Sorry to interrupt. I just wanted to, before you go with your method, I just wanted to troubleshoot something. When I saw the fraction, so I saw that somehow if I just see that how much reduction is there in every single number. Like if I divide it by 13, divide by 13 minus 2. So every deduction is 2, but the smallest would be 11. So the major change would happen if I divide minus 2 from 11. So that would be a major change. So I think that could be the
Right.
greater. It was just my
Yes.
logic before you start.
Yes, yes, yes. But see, in your words, if I just interpret your word, so you are saying that could be the greater, right? So still with this method, you are not getting a surety, right?
Yes.
That whether this is a greater or not. right? So this way you can just eliminate some options, right? And then you can just actually multiply, or maybe using say some other method to identify yes or no, this is a greater or not greater, right? So there is this cross check is also there, right? But the thing which I am using here, in a one way, in a one time, you are sure that okay, this one is greater or not, right? So just see this. Third fraction is what? 11 by 9. I can write this as 1, 2 by 9, right? And the last one is 12 by 10. So this is what? 1, 2 by 10, right? So these are in mixed fraction form. So in every fraction we have 1, 1, 1, 1. Numerator is 2, 2, 2, 2, 2, right? Only the one thing is different, that is denominator. And what I need? Greater out of the 4. So where the denominator is smallest, right, fraction will be greater. So if I range, or if I maybe say, if somebody asks me, okay, arrange them in an order, right? So from greater to smaller, right? So this one is greater 1, top one, right? Greatest one. Done. Then after this is greater 2. This is the second greatest one. Done. And this is greater 3. This is the third greatest. And this is greater 4. Or you can say this is the smallest one. Right. So this way, if anybody is asking you to arrange the order, right, so you can just arrange them in a proper order, right? And this is again without any calculation, multiplication, LCM method, crisscross method, right? But yes, we have to solve, say, good varieties of question, good number of questions, so that we come to know, okay, these are our method, and they just settle in our mind, right? So I suggest everyone to just take a say study material which you have got from the head office of British Shastra, the PDF books, right? And then the online test portal. So there you can just attempt the questions, so that you have a more exposure, more clarity about the methods. So Hardik, PDF, I do not have the PDF. Basically, just check the emails which you have got from the head office, that is from the support@edukashastra.com, right? And in those emails, you must be having a PDF, or maybe some Google Drive link from where you can download the books, right? Okay.
सर डाउट सेशन कब से स्टार्ट होंगे हमारे?
डाउट सेशन भी आ जाएगा, उसका भी शेड्यूल आपको जो है टाइम टेबल के साथ में बहुत जल्दी ही मिल जाएगा, है ना? बहुत जल्दी मिल जाएगा।
सर हम सब लोगों को टेलीग्राम या फिर कोई व्हाट्सएप ग्रुप वगैरह नहीं बनेगा?
आई थिंक फेसबुक का है ना, तो फेसबुक पे जो है वहां पे आप कनेक्ट करो, फेसबुक का है।
ओके सर, ओके,
है ना? So Hardik, you joined. Okay, so you joined recently, right? So nothing to worry. Maybe in a day or two, you will get an email from the head office, and you will get all the books in the PDF form, right? So then you can start solving the questions with the help of book. Right? So in the meantime, I suggest that all of you should start solving the questions for the ratios from the book, right? And in the next session, we will be moving from this point onward after the comparison of the ratios. So the next one is, right, some questions based on this, and then we are moving to the term proportions, right? Yes, Akshay. So whatever the topics you are done, right? So first solve the say the order of study should be what? First, read the chapter thoroughly, okay, and then solve the solved example, right? So that you can understand, okay, what are the concepts we are just studying here. So this is just one more time revision. After the reading of the chapter and the solved examples, you start solving the practice exercise in the book, right? So now you are applying the concepts in solving the questions. When you are done with the book, the practice exercise, right, you just move to the online portal for attempting the test of the related topic, right? So this way you are completing, right? Okay.